Hello, in this video we're going to look at finding the equation of a tangent line given a function and a point. So we're going to find the equation of the line tangent to the function f of x equals x cubed minus 4x squared plus 3 equals 1 at the point where x is equal to 1. So the first thing we need to do to find the equation of the line, we need to know a point and we need to know the slope. So first let's find our point. So what is f of 1? F of 1, if we plug in 1 for x, we're going to get 1 cubed minus 4 times 1 squared plus 3, and that's going to be 1 minus 4 plus 3 is 0. So that means that a graph is going to go through the point 1, 0. Now in order to find the slope, our slope is going to be equal to our derivative evaluated at 1. So we need to find our derivative. So the derivative of this function here is going to be using the power rule. X cubed, the derivative is 3x squared. Negative 4x squared is going to be negative 4 times 2 x to the first, and then that plus 3 is a constant, and so our derivative is going to be 0. So if we wanted to find the slope there, we're going to plug in 1 for x, and we get our slope is negative 5. So now we have our point and our slope. Now we can plug into the point slope form of a line, y minus y1 equals m times x minus x1, where our point is the point 1, 0, and our slope is negative 5. So we get y minus 0 equals negative 5 times x minus 1. And that's going to be y equals negative 5. If we distribute negative 5, we'll get negative 5x plus 5. So that would be the equation of the tangent line. Now, in order to find what that actually means, let's look at this on the calculator. If we go to our y equals menu and enter our original function, and then we enter that tangent line that we just found, and then I'm zooming in on x equal 1. So I'm just going to go from x equals 0 to x equal 2. And I know that the y value is 0, so I'm kind of zooming in on that a little bit as well. So if we look at our graph, what we see is here is our cubic function, and then our tangent line comes in, and it gets really close. In fact, at that point, it's going to go through that point. And we can also look at the table. You can go to your table set, which is second window, and change some of the settings. I'm going to change my delta table. Default is for it to be at 1. I'm going to change it to 0.1 just so we can get a little bit closer in on the graph. And then if we look at our table, second graph, looking at x equal 1, we see that those y values are the same. y1 is our function, y2 is our tangent line. And so at 1, they have the same y value. And if we go to either side of it, it's really close. We get 0.489 on our function, and we would estimate that at 0.5 on our tangent line. At 1.1, it's negative 0.509, but our tangent line is at negative 0.5, and we can see that the further we get away, the further off it gets. If we go down even further, it gets off more, and by the time we get to, that actually, normally it doesn't give you that same value. But if we go the other direction, we see that these numbers start getting, by the time we get all the way down to 0, it's quite a ways off, 1.5 off, 2 off by the time we get to 0. And so a tangent line can help us approximate our function really close to the value that we're looking at. All right, I'll see you guys next time.